Anugraha, Adira, Nandana, Abhishek, Ananya, Vismaya, Prof, good evening. So we have done this, done. Last class we were discussing about center of mass, done. Yeah. What was the last point? Angular momentum. Next is a derivation. Relation between torque and angular momentum. Torque and angular momentum. It's a relation between torque and angular momentum. We have to do this derivation between torque and angular momentum. Okay, relation between torque and angular momentum is our next topic. Let's see relation between torque and angular momentum. Now remember, L vector is equal to R vector cross P vector. So this is equation 1. Differentiating equation 1, we get dl by dt is equal to d by dt of R vector cross P vector. dl by dt is equal to d by dt of R vector cross P vector. So here you should apply product rule of differentiation. D by dt of uv is equal to, this is the product rule of differentiation. First into derivative, first into derivative of second plus second into derivative of first. This is the format. What is that? First into derivative of second. What is in by derivative of second? dv by dt. Plus second is what? v into derivative of first, du by dt. So applying dl by dt is equal to dr into dp by dt plus p into dr by dt. Now, according to Newton's second law of motion, what is force? Rate of change of momentum is what? Force. 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 So dl by dt is equal to R vector cross, instead of dp by dt I can write f vector plus, what is f equal to f dp by dt? We know that momentum p vector equal to what? Mass into velocity vector. So instead of p vector I can write what? Mass into velocity vector, then dr by dt, rate of change of position with respect to time, or dr by dt is equal to velocity. So mv vector cross v vector. Remember, instead of momentum I have written mass into velocity vector. Instead of dr by dt I have written v vector. But I know that a vector cross a vector or v vector cross v vector is equal to what? Cross product of similar vectors will be what? 0 vector. So dl by dt is equal to what? dl by dt is equal to r vector cross f vector plus m into 0. That is 0 only. But we know that r vector cross f vector is what? Torque. Torque tau vector. Torque. So dl by dt is equal to what? Torque. dl by dt is equal to torque, which means what? That is rate of change of angular momentum. Rate of change of angular momentum gives torque. Rate of change of angular momentum gives torque. Rate of change of angular momentum gives torque. Thus, we have proved that relation between torque and angular momentum. Rate of change of angular momentum ആണ് എന്ത്? Torque. Any doubt? Rate of change of angular momentum ആണ് എന്ത്? Torque. Any doubt regarding that? മക്കളെ ഡൗട്ട് ഉണ്ടോ? റേറ്റ് ഓഫ് ചേഞ്ച് ഓഫ് ആംഗുലർ മൊമെന്റ് ആണ് എന്ത്? ടോർക്ക്. ഡൗട്ട് ഉണ്ടോ? നോട്ട് ചെയ്യട്ടോ. നോട്ട് ചെയ്യട്ടോ. നോട്ട് ചെയ്ത് കഴിഞ്ഞാ നെക്സ്റ്റ് ലോ ഓഫ് കൺസർവേഷൻ ഓഫ് ആംഗുലർ മൊമെന്റം. ലോ ഓഫ് കൺസർവേഷൻ ഓഫ് ആംഗുലർ മൊമെന്റം. Law of conservation of angular momentum. What is that? If external torque is 0, angular momentum will be a constant. Angular momentum will be a constant. If external torque is 0, angular momentum will be a constant. External torque 0 means what? What is our last equation? dl by dt is equal to what? Rate of change of angular momentum is what? Torque. If external torque is equal to 0 means what? Tau external equal to 0 means what? dl by dt is equal to 0. Which means what? dl equal to 0 into dt cross multiplying. That is dl equal to what? 0. So if change in angular momentum, if change in angular momentum is 0, if change in angular momentum is 0, angular momentum will be a constant. Angular momentum will be a constant. dl stand for change in angular momentum. Change in angular momentum is 0 means what? L equal to constant. So what is law of conservation of angular momentum? If external torque equal to 0, angular momentum will be a constant. Any doubt? Any doubt regarding this? If external torque is equal to 0, angular momentum will be a constant. Note data. Law of conservation of angular momentum. If external torque equal to 0, angular momentum is a constant. Done? Yeah. Done. Yeah. Next topic is equilibrium of a rigid body. If equilibrium of a rigid body, there are two equilibrium: translational equilibrium and rotational equilibrium. According to Newton's second law, according to Newton's second law of motion, Newton's second law of motion. What is that? Rate of change of momentum is force. F external force equal to dp by dt. We have d by dt of instead of momentum p, we can write what? Instead of momentum p, we can write what? Mass into velocity. So instead of d by dt of p, we can write mass into velocity. But mass is a constant, so it is taken outside the differentiation. So m into dv by dt. Now we have already seen that if a body is in translational equilibrium, velocity will be what? Constant. That means what? dv by dt is equal to what? 0. If a body is in translational equilibrium, rate of change of velocity is 0. Why dv by dt is 0? If a body is in translational equilibrium, velocity will be a constant. So what will be change in velocity? 0. Change in velocity will be what? 0. That means what? External force is equal to m into d. Instead of dv by dt, I am writing what? 0. So external force is 0. So what is our conclusion? If a body is in translational equilibrium, external force on the body will be what? 0. What is our conclusion? If a body is in translational equilibrium, external force on the body will be what? 0. If a body is in translational equilibrium, external force on the body will be what? 0. Any doubt? മക്കളെ ഡൗട്ട് ഉണ്ടോ? മനസ്സിലായോ? അപ്പോൾ ബോഡി ട്രാൻസ്ലേഷണൽ ഇക്വിലിബ്രിയത്തിലാണെങ്കിൽ 2 പോയിന്റ്. ഒന്ന് വെലോസിറ്റി കോൺസ്റ്റന്റ് ആവും. സെക്കൻഡ് പോയിന്റ് ഈസ് വാട്ട്? External force will be what? 0. Any doubt? Please note down translational equilibrium. Translational equilibrium. നോട്ട് ചെയ്യട്ടോ. Done. So if a body is in translational equilibrium, its velocity will be constant. So change in velocity will be 0. External force will be 0. Any doubt? Any doubt? Done. Next, condition for rotational equilibrium. Condition for rotational equilibrium. For a rotating body, I will write external torque is equal to what? Rate of change of angular momentum. Now remember, momentum is equal to, now before taking that I should take another topic. That topic is moment of inertia. See, it's a very important topic. What is this topic? Moment of inertia. It is a very important topic. Moment of inertia of a particle of mass m. Suppose there is a particle of mass m. There is a particle of mass m at a distance r. Suppose this body is rotating with an angular velocity omega. Distance from the axis of rotation to mass m is r. Then moment of inertia I is equal to mr square. What is moment of inertia? Moment of inertia of a particle of mass m rotating about an axis at a distance r from the axis is given by I equal to mr square. In the case of a rigid body, Anugraha, sir, okay, let me complete this. In the case of a rigid body which consists of a large number of particles, what will be the total moment of inertia? I is equal to m1r1 square plus m2r2 square plus etc. plus mn square. This can be written as moment of inertia I is equal to sigma over I equal to 1 to n mi ri square. This is the equation for moment of inertia of a rigid body having n particles. Having n particles. Any doubt? What is the SI unit of moment of inertia? It is mass into distance from the axis of rotation square. So kilogram meter square. Dimensional formula is what? ml square. Any doubt? Any doubt? Moment of inertia? What is moment of inertia? If a rigid body rotates about an axis with angular velocity omega, consider a particle of mass m on the rigid body. That particular particle is at a distance r from the axis of rotation. What is moment of inertia? It is a product of mass and square of distance from the axis of rotation. I equal to mr square. What is its SI unit? Kilogram meter square. What is its dimensional formula? ml square. For n particle system, sigma over I equal to 1 to n mi ri square if there are n particles. Any doubt here? Makkale doubt unda? Moment of inertia doubt unda? Anugrah was asking momentum constant ആവോ? അത് കഴിഞ്ഞ ടോപ്പിക്കിലാണ്, അതുകൊണ്ട് ഞാൻ സെപ്പറേറ്റ് ബോക്സിലായിട്ട് എഴുതാണ്. ശ്രദ്ധിക്കുക, എക്സ്റ്റേണൽ ഫോഴ്സ് ഈസ് ഈക്വൽ ടു എന്താ? റേറ്റ് ഓഫ് ചേഞ്ച് ഓഫ് മൊമെന്റ് ആണ്. നേരത്തെ പറഞ്ഞു ഇഫ് എ ബോഡി ഈസ് ഇൻ ട്രാൻസ്ലേഷണൽ ഇക്വിലിബ്രിയം. ട്രാൻസ്ലേഷണൽ ഇക്വിലിബ്രിയം മീൻസ് വാട്ട്? External force has to be zero. External force has to be zero. If external force is zero, dp by dt is what? Zero. That means what? dp is equal to what? Zero. That means what? p equal to constant. So Anugraha, what you have said is correct. Because if a body is in translational equilibrium, external force zero. External force zero means what? Change in momentum will be zero. That means momentum is a constant. So you can add that to the properties of translational equilibrium. External force zero, velocity constant, momentum constant. Any doubt? Velocity is constant means what? Mass is obviously a constant. So momentum will be a constant, right? Anugraha, is it clear? Yeah, clear. Please note down moment of inertia. Moment of inertia note here. നോട്ട് ചെയ്യട്ട, ആ ഓറഞ്ച് കളറിൽ ബോക്സിലാക്കിയിട്ട് എഴുതിയത് നോട്ട് ചെയ്തോളൂ. മൊമെന്റ് ഓഫ് ഇനർഷ്യ. Distance from the axis of rotation into mass into square of distance from the axis of rotation. Mass into square of distance from the axis of rotation. Done? കഴിഞ്ഞ എഴുതി കഴിഞ്ഞ മക്കളെ, എഴുതി കഴിഞ്ഞ ഡൺ വിചാരിക്കണം. Okay. Now, very important, what is the physical significance of moment of inertia? Physical significance of moment of inertia. What is moment of inertia? We know mass is what? Inertia. So if I am a heavy mass person, then I cannot change my direction easily, because mass is a form of inertia. Higher the mass, greater will be inertia. That is in linear motion or translatory motion. But in rotational motion, moment of inertia plays the same role as mass does in linear motion. ലീനിയർ മോഷൻ ഓർ ട്രാൻസ്ലേറ്ററി മോഷനിൽ മാസ് എന്ത് ചെയ്യുന്നു, അതേ റോള് റൊട്ടേഷണറി മോഷനിൽ ചെയ്യുന്ന ആളാണ് ആര്? മൊമെന്റ് ഓഫ് ഇനർഷ്യ. ലെറ്റ്സ് സീ ദ ഇനബിലിറ്റി ഓഫ് എ ബോഡി, inability of a rotating body to produce any change in its state is called rotational inertia or moment of inertia. Moment of inertia depends not only on the mass but also distribution of mass about the axis of rotation. Moment of inertia depends not only on the mass but also distribution of mass about the axis of rotation. Moment of inertia in rotational motion plays the same role as mass does in linear motion. Any doubt? Very, very important. Physical significance of moment of inertia. Very, very, very important. Any doubt? മക്കളെ ഡൗട്ട് ഉണ്ടോ? ഡിസ്ട്രിബ്യൂഷൻ അബൌട്ട് ദ ആക്സിസ് റൊട്ടേഷൻ എക്സ്പ്ലെയിൻ ചെയ്യുമോ? ആരതി, when you cycle, okay, let others come finish writing, then I will explain. Yeah, Aradi, when you cycle, I am trying to draw a figure of cycle. Okay, suppose this is a handle. Okay, a person is sitting on the cycle. So what will happen? He or she drives the cycle for certain period of time. Suppose I am driving the cycle, what I will do? After pedaling for 5 seconds, then I will simply stand on, means sit on the cycle. Cycle by itself, it will move. Why? Because of moment of inertia. Because a rotating body continues to be in its state of rotation because of moment of inertia. Now, why the distribution of mass is important? In cycles ring, you can see when you examine the wheel of the cycle, you can see that what you are seeing, mass is concentrated away from the axis of rotation. The wheel will be thicker at this side. The mass is heavy away from the axis of rotation. Why it is distributed like this? Because R value is greater. When R is increased and mass is increased, what happens? Moment of inertia increases. I equal to mr square, m and R is increased. So what happens? After pedaling 2-3 times, you can simply sit on the cycle. Cycle by itself, it will move because of moment of inertia. Then I went to during Thrissur Puram, we are taking the class from Thrissur. There is a Puram festival here. During Thrissur Puram, there will be giant wheel. മലയാളത്തിൽ യന്ത്രൂഞ്ഞാൽ എന്ന് പറയും. ഈ giant wheel having different cubicles and persons will be sitting inside the cubicle. Again, here mass is distributed away from the center. So, in Puram, this giant wheel is run by electric motor. But if you go to simple small festival in temples or small churches, you can see this small giant wheel model where kids sit. What they will do, there will be a person who just rotates a lever. Initially, he has to put a large effort. Why? Because of moment of inertia, it resists a change. Initially, it is at rest. So, when you try to move this wheel, initially it will resist because it opposes the change in rest. But once it is in motion, Arati, what happens? Once the person who putting an effort to rotate, no, once the this small wheel is in motion, he can simply leave from that. Why? Because due to inertia, due to what inertia? Moment of inertia, it will continue the rolling motion. Now, how to do it effectively? You have to make sure that these cubicles are stored or cubicles are placed away from the axis of rotation. Why? Here, if you place it away, R value is increased and the kids are sitting here, mass is increased here. So, what happens? Moment of inertia increases, I equal to mr square. Now, Aradi, suppose all the kids are very close to the center of the axis of rotation. In this case, then you have to put lot of effort. Why? Here, distance from the axis is lesser. R value is lesser. When R value lesser, R square lesser. So, moment of inertia is mr square. Although the mass is same, moment of inertia will be lesser. Why? Because the distance from the axis of rotation is lesser. So it depends not only on the mass but distribution of mass also. That is also important. Any doubt? Any doubt? മക്കളെ മനസ്സിലായോ? Yeah. So momentum P equal to mass m into velocity v. P equal to mv. Similar to that, angular momentum L equal to radius r into angular momentum L equal to, instead of mass, I can write moment of inertia, because moment of inertia plays the same role as mass does in linear motion. So I am writing moment of inertia. Instead of velocity, I can write angular velocity. That means what? Angular velocity omega. That means what? L equal to I omega. Momentum P equal to mass into velocity. Angular momentum L equal to I omega. Any doubt? Momentum P equal to mass into velocity. Angular momentum L equal to what? I omega. Any doubt? So, in translatory motion, this motion is what? This motion is what? Translatory motion. Translatory motion or linear motion. Or linear motion. What we have? Momentum. In rotational motion, what we have? Angular momentum happens in what motion? Rotational motion, what we have? Angular momentum. Now remember, L can be written in other format also. L equal to mass into velocity into radius. That is also there. L equal to R vector cross P vector. That we have seen. L equal to mr square omega. All these equations represents angular momentum. Any doubt? All these equations represents angular momentum. Any doubt? മക്കളുടെ ഡൗട്ട് ഉണ്ടോ? അങ്ങനെ ഒരുപാട് ഇക്വേഷൻസ് ഉണ്ട് ആംഗുലർ മൊമെന്റത്തിന്. നോട്ട് ചെയ്താ? നോട്ടഡ് റൈറ്റ്? നമുക്കിനി ബാക്കിലോട്ട് പോവാം. നമ്മളൊരു കാര്യം ഇവിടെ പറഞ്ഞു നിർത്തിയിട്ടുണ്ടായിരുന്നു. കണ്ടീഷൻ ഫോർ റൊട്ടേഷണൽ ഇക്വിലിബ്രിയം. For rotating body, P equal to what? Mass into velocity, linear momentum, angular momentum L equal to moment of inertia into angular velocity. So external torque is equal to, instead of L, I can write d by dt of I omega. But if a body is in rotational equilibrium, omega will be what? Constant. If a body is in rotational equilibrium, omega will be a constant. Omega constant. Omega will be what? Constant. I is what? Now before that, moment of inertia is a constant, because moment of inertia I equal to what? mr square, which is constant for a given body. So I is taken outside the differentiation. So external torque is equal to what? I into d omega by dt. But if body is in rotational equilibrium, translational equilibrium, velocity constant, rotational equilibrium, angular velocity constant. if body is in rotational equilibrium, angular velocity omega will be constant. Angular velocity omega will be constant. So d omega by dt is equal to what? 0. That means what? External torque equal to 0. So if a body is in rotational equilibrium, if external torque acting on it is 0. Any doubt? Doubt now? This I have to complete it because you are not aware of moment of inertia. That's why I did explain moment of inertia and come back here. Any doubt? So we are done with the translational equilibrium. Translational equilibrium, what were the points? External force 0, velocity constant, momentum constant. Rotational equilibrium, what are the points? External torque 0, angular velocity constant. Angular momentum is also constant. Okay, continuing. Just concluding. Translational equilibrium, one side, and the other side we have rotational equilibrium. Rotational equilibrium. So what are the points in translational equilibrium? Points in translational equilibrium, what are they? External force 0, external force 0, velocity constant, momentum constant. Momentum constant. Rotational equilibrium, external torque 0, angular velocity constant, angular velocity constant, Angular momentum also counts. Momentum also counts. Linear momentum P, angular momentum L. Velocity V, angular velocity omega. Note down. Note it down. Done. Done. All of you done? Note it down. Next, it's a tough section. Principle of moments. It's not easy to understand principle of moment. Let me tell you, it's not that easy. Okay, I will do it separately. Next topic, principle of moments. Principle of moments. See, here there is a fulcrum. This is called fulcrum. One force here, F1. Here we are applying a force F1, which is at a distance R1, or is it D1? What is written there? I think it is D1. Here, D1. It is D1. One force F1 is at a distance D1. Another force F2 is at a distance D2. Another force F2 is at a distance D2. For translational equilibrium. Translational equilibrium. So what is the condition for translational equilibrium? External force should be what? 0. See, if this is fulcrum, this will be what? Normal reaction. Translational equilibrium means what? R minus F1 minus F2 is equal to 0. Why I am writing that? Because the total force should be 0. Here F1 and F2 forces are acting downward direction. Normal reaction is in the upward direction. If I am taking normal reaction as positive force, then F1, F2 should be negative. But if the body is in translational equilibrium, the net force acting on the body should be 0. What is the net force? Sum of all the forces. Here upward forces taken as positive, downward forces is taken as negative. So R minus F1 minus F2 is equal to 0, which means what? R equal to F1 plus F2. This is the condition for translational equilibrium, where what is R here? R is the normal reaction. Normal reaction. മനസ്സിലായോ? എന്തെങ്കിലും ഡൗട്ട് ഉണ്ടോ? അപ്പൊ ചില കുട്ടികൾ പറയും സാറേ F1 F2 പോസിറ്റീവ് എടുത്തൂടെ, F1 F2 പോസിറ്റീവ് എടുക്കുകയാണെങ്കിൽ എന്താ F1 plus F2 minus R equal to 0. Then also you will get the same answer, F1 plus F2 equal to R, which is R equal to F1 plus F2. Any doubt? That is a condition for translational equilibrium. Any doubt? നോട്ട് ചെയ്യണേ, സ്റ്റെപ്പ് ബൈ സ്റ്റെപ്പ് പോയാലേ മനസ്സിലാവുള്ളൂ. നോട്ട് ചെയ്യണേ. 6 നോർമൽ റിയാക്ഷൻ ട്ടോ. ഡൗട്ട് ഉണ്ടോ? ഡൗട്ട് ഉണ്ടോ? നോട്ട് ചെയ്താ. So that was done with about translational equilibrium. Next what we have? Rotational equilibrium. So next I am doing rotational equilibrium. Rotational equilibrium. So what is the condition here? For rotational equilibrium, net torque should be 0. Net torque should be 0. Net torque should be 0. That is a condition for rotational equilibrium. Let's see what is net torque. What is net torque means what? Torque is moment of force. Torque is also called what? Moment of force or rotational force or rotational force. Moment of force or rotational force. Okay. Now here, if anti-clockwise moment, what is moment? Force into distance. What is this torque? Force into distance from the axis of rotation. So first force is what? F1 into D1 is equal to what? Not is equal to, minus F2 into D2. That is a net torque is equal to 0. Any doubt? So here I have followed a method in which anti-clockwise moments are taken as positive and clockwise moments are taken as negative. Anti-clockwise means what? F1 is acting in the anti-clockwise direction, where F2 is acting in the clockwise direction. So I have taken anti-clockwise moment F1 D1 positive, clockwise moment anti-clockwise moment F1 D1 positive, clockwise moment F2 D2 negative. Even if you take in the opposite way, still you will get the same equation. That means what? F1 D1 is equal to what? F2 D2. That is F1 by F2 is equal to F1 by F2 is equal to D2 by D1. In practical case, suppose, please concentrate, while I was a kid, my house was a very small house, and there was a big coconut tree, very big coconut tree, very close to my house. So at the rainy season, I used to worry whether this coconut tree will fall onto my house. So at one day, my family decided to cut this coconut tree. So this wood cutting team came. They cut this coconut tree into small pieces. I was wondering how they are going to move this big coconut tree pieces. How they are going to move this big coconut tree pieces. Now what they did, they applied this principle of moments. They used a very big rod. And they placed fulcrum here. This is fulcrum. Maybe you can simply say axis. So what is this coconut tree wood? This is the load that has to be moved. And this is the effort the workers have to put. Effort. So what is this distance? This distance is called from load to axis of rotation. Fulcrum means what? Axis of rotation. It is applied at the axis of rotation. Axis of rotation is through the fulcrum. So let's see. This is load and this distance is what? D1. Or not D1. I should call it as load arm. Load arm. I am going to apply, I am supposed to apply the effort here. So this is effort. When you compare the previous figure, this load is F1 and this distance is D1 and effort is F2 and this distance is what? D2. This distance is what? D2. Now, by principle of moments, what you will get? Mechanical advantage MA is denoted by MA. Mechanical advantage MA is equal to load by effort. Mechanical advantage MA is equal to what? Is equation? Load by effort. What is load? What is it? Okay, I have written there. Better to write here. Mechanical advantage is equal to load by effort. What is load here? F1 by F2. Now we know that F1 D1 is equal to what? F2 D2. That is, F1 is what? Load into load arm is equal to what? Effort into F2 is what? Effort into effort arm. Now what is mechanical advantage? Mechanical advantage is load by effort. So mechanical advantage is equal to load by effort. What is load by effort? Which is what? Load is what? F1 by effort is what? F2 is equal to what? Effort arm by load arm. Effort arm by load arm. What is effort arm? D2. What is load arm? D1. So mechanical advantage is equal to load by effort is equal to, I can simply write what? Effort arm by load arm. What is mechanical advantage? That is a concept behind machines. See, why we are going for machines? Because we are getting mechanical advantage. That means with less mechanical effort, our task is done. I repeat, what is meant by mechanical advantage? That is a principle behind machines. With less mechanical, why we are going for machines? Machines are having mechanical advantage. So with less effort, we can move what? maximum load. So mechanical advantage is equal to load by effort is equal to effort arm by load arm. Now what is our purpose? Our purpose is to increase mechanical advantage. So what should be my effort? Effort should be minimum. And what should be my load? Load should be maximum. Similar to that, load arm should be minimum, effort arm should be maximum. So is this the correct way I have done it? Yes. My effort arm is larger, effort arm is high. Why I am keeping in this position? If I place the fulcrum or axle rotation close to the load, my load arm will be minimum and my effort arm will be what? Maximum. Why I am placing so? By increasing, by making load arm minimum and effort arm maximum, I am getting what? More mechanical advantage. Sir, appo sum of clockwise momentum, sum of anti-clockwise momentum equal ആവില്ലേ? എങ്ങനെയാണ് ഈക്വൽ ആവണേ? D1 is not equal to D2, right? എനിക്കത് മനസ്സിലായി. Sum of clockwise momentum and sum of, yeah, that will be equal. So that is the reason why external torque is 0, right? അതുകൊണ്ടാണല്ലോ അതിപ്പോ നേരത്തെ ഈക്വൽ ആയിരുന്നില്ല അനുഗ്രഹ. നമ്മുടെ റൊട്ടേഷണൽ ട്രാൻസ്ലേഷണൽ ഇക്വിലിബ്രിയത്തിലും അത് തന്നെയല്ലേ ഉണ്ടായേ. ഇതേ കേസിലെ ട്രാൻസ്ലേഷണൽ ഇക്വിലിബ്രിയം നോക്കിയാലോ, ഇവിടെ എന്താ ഉണ്ടായേ? R equal to F1 plus F2 അല്ലേ? Normal reaction should balance what? F1 plus F2, right? In translational equilibrium same thing happen. That will be equal. Normal reaction should balance what? F1 plus F2. Listen, what is translational equilibrium? External force should be 0. That is sum of all forces should be 0. What is rotational equilibrium? External torque should be 0. That sum of all torque should be 0. That means what? Downward moment should be equal to what? Upward moment. That is the reason why clockwise moment should be equal to what? Anti-clockwise moment. Here, translational equilibrium, downward forces are what? Balanced by upward normal reaction. That is in translational equilibrium. In rotational equilibrium, what happens? Clockwise moments are balanced by anti-clockwise moments. Doubt? Any doubt? So earlier, while taking classes, I used to have a confusion. When I derive, there is no confusion. When I write it, no. Only equation I used to get a confusion whether mechanical advantage is load by effort or effort by load. In early, when I first came to teaching. So I used to remember in this way, male. What is that? Male. MALE ആണ് എന്ന് പറയില്ലേ നമ്മൾ. MALE. ഞാൻ ഓർക്കാൻ വേണ്ടിയിട്ട് ചില കുട്ടികൾക്ക് ഒരു കൺഫ്യൂഷൻ എപ്പോഴും ഉണ്ടാവും. എനിക്കുണ്ടായിരുന്നു ആ കൺഫ്യൂഷൻ. അത് ഒഴിവാക്കാനാ പറയണേ. MALE എന്ന് ഓർത്താ, മെയിൽ. Mechanical advantage is equal to what? Load by effort, which is equal to what? Effort arm. Arm വരുമ്പോ armന്റെ length വരുമ്പോ opposite ആണ് effort arm by load arm. So with this technique, the persons who came for work to move my coconut tree were very simply they were able to move it because with this concept. Any doubt regarding this? ഡൗട്ട് ഉണ്ടോ? നോട്ട് ചെയ്യോ? കുറച്ചധികം ഉണ്ട് നോട്ട് ചെയ്യാൻ. എല്ലാവരും നോട്ട് ചെയ്യട്ടോ. കഴിഞ്ഞ നോട്ട് ചെയ്തോ? ലോഡും എഫേർട്ടും എല്ലാം നോട്ട് ചെയ്തോ? Next time, suppose you want to move a big rock. How to do that? Should you place at the middle? Is this the way? Is this the way? This is the wrong way to move, isn't it? This is the wrong way, right? Done. This is done. See, here it is clearly mentioned that in order to move this big load, where you should place the fulcrum. This is what? Fulcrum. Fulcrum should be placed closer to the load. So, load arm is lesser. Load arm minimum. This is effort arm. Effort arm high. Load arm low. Any doubt? Clear alle? Load arm should be kept small and effort arm should be kept high. Yeah. Next, this is a very simple topic. Distinguish between center of mass and center of gravity. Center of mass. Center of mass is the point where all mass of the body can be assumed to be concentrated. Center of gravity is the point where all weight of the body can be assumed to be concentrated. If G remains constant throughout the space of the body considered, then the center of mass and center of gravity are identical, otherwise different. That we have discussed before. Moment of inertia I have explained. This is also done. This I have explained. This I have explained. Yeah, next is a tricky one. We have to by heart a table. This thing, it's a sure question. This thing you have to by heart. There is no logic here. Simply by heart it. Moment of inertia, some regular shaped bodies without a specific axis. What is the first body? What is the first body? Body thin circular ring of radius r. This is capital letter R. Axis perpendicular to the plane. This is the ring. Axis perpendicular to the plane. What is the moment of inertia? Mr square. How we are getting this moment of inertia, that is not required. Simply by heart, its moment of inertia is mr square. Thin circular ring, radius or axis is along the diameter. So, where axis is along the diameter, what is the moment of inertia? Mr square by 2. Then thin rod of length L, axis perpendicular to rod at a midpoint. So, this is the rod and this is the axis. Suppose this is the rod and this is the axis. What is the moment of inertia? ml square by 2, where L is the length. Then what is the next case? Circular disc, axis perpendicular to disc at the center. Suppose this is a disc and axis is perpendicular to the disc. What is moment of inertia formula? mr square by 2. Please note down this. ഈ ഓരോ ഫിഗർ വരച്ച് നോട്ട് ചെയ്യണം. കുട്ടികൾ ഇത് അത്ര ഇമ്പോർട്ടൻ്റ് ആയിട്ട് കാണില്ല, ബട്ട് യു ക്യാൻ എക്സ്പെക്ട് ദിസ് ഫോർ ദ ക്വസ്റ്റ്യൻ പേപ്പർ, ഫോർ ദ എക്സാം. ഇറ്റ്സ് യൂസ് ടു കം ഫോർ ദ എക്സാം. Moment of inertia of some regular shaped objects. ആ ഫിഗറുകൾ നോട്ട് ചെയ്യാട്ടോ. ആ ഓരോന്ന് ഫിഗർ വരച്ച് നോട്ട് ചെയ്യുക. പ്ലീസ് ബൈ ഹാർട്ട് ദോസ് moment of inertias of different regular shaped objects. You have to by heart those moment of inertia. I hope all of you done. Next, this shape, circular. Circular disc of radius r, axis along the diameter mr square by 4. Hollow cylinder, axis along the cylinder mr square. Solid cylinder, solid means fully occupied, hollow cylinder you know. Then it becomes mr square by 2. Solid sphere 2 by 5 mr square. Please note down. Solid sphere 2 by 5 mr square. Please note down. Done? Noted, right? All of you done? Noted? Already done. Okay. So next, point is radius of gyration, which is a very important topic, and it is not easy for students to understand what is radius of gyration. Suppose a rigid body is rotating about an axis with angular velocity omega. Suppose this is radius of gyration, this distance is radius of gyration, then if I want to call this distance as radius of gyration, then this point should have mass of the whole body. At this point, there should be what? Mass of the whole body. So I is equal to mk square. K square equal to what? I by m. So what is radius of gyration? It is the distance from the axis of rotation to a mass point. But what is the speciality of that mass point? That should have mass of the whole body, whose mass is equal to mass of the whole body, and whose moment of inertia is equal to moment of inertia of the whole body about that axis. It is confusing for students. Suppose there is a rigid body, it is rotating about an axis with angular velocity omega, and I am calling this particular distance as radius of gyration k. How can I call that particular distance as radius of gyration? There are two conditions for that. The point and the mass at this point should be equal to what? Center of mass. Or you should say that the whole mass of the body should be assumed to be concentrated at that point. And moment of inertia at that point will be equal to what? If you find out moment of inertia at this point, then that will be equal to what? Moment of inertia of the whole body. If these two conditions are satisfied, then we can call this distance as what? Radius of gyration. K equal to root I by m. So what is the unit of radius of gyration? Unit meter, because it is radius, right? So unit meter. Dimensional formula is what? L. Dimensional formula L. Dimensional formula L. Since it is distance. Any doubt? Any doubt? Doubt now? Note ചെയ്യട്ടോ. Radius of gyration note ചെയ്യട്ടോ. Radius of gyration definition note ചെയ്യുക. It is a distance from the axis of rotation to a mass point whose mass is equal to mass of the whole body and whose moment of inertia is equal to moment of inertia of the body about that axis. Note ചെയ്തെല്ലാവരും? All of you noted? All of you noted, right? So I'm stopping today. So next class we will be continuing with the radius of different bodies. So thank you all. Thank you. Good night. Thank you.